This is the second half of today's lesson involving independent and dependent events, Chapter 8, Section 6. So let's take a look at this problem here. Number 5, it talks about Callista has 4 $1 bills, 2 5s, 3 10s in her wallet, and she has 2 California quarters, 3 Washington quarters. If she randomly chooses 1 bill and 1 quarter from her wallet, what is the probability that she chooses a dollar bill, a $1 bill, and a California quarter? Well, does it really matter if she's got these bills and got these quarters? Does it matter that she chooses a $1 bill, a $5 bill, or a $10 bill? Will that have an effect on the type of quarter that she picks, either a California or Washington? No, it doesn't. It doesn't matter whether she picked a dollar bill, a $5 bill, or a $10 bill. That has no effect on the California quarter that she's going to end up trying to pick. So this is an independent event. One does not affect the other. And so let's start by writing a probability for the $1 bill. So probability of selecting a $1 bill. And then let's take a look at the probability of selecting the California quarter. So there's our $1 bill. Probability of a California quarter is our next probability. And what we're going to end up doing with these is multiplying them, because they want to know whether it's going to, with the probability of doing 2 things together. And the key word is and. So when we see the word and, we're typically going to end up multiplying these probabilities. When we see the word or, that's when we had what we did yesterday, where we had disjunctions and when we ended up adding the probabilities together. So probability of a $1 bill. Let's count the number of $1 bills. Well, we have 4 $1 bills, it says. So that's 4 out of how many total? Well, we have 4 plus 2 plus 3. So we got to add up all those numbers. 4 plus 2 plus the 3. Now we're going to multiply this by the probability of selecting California quarter. How many California quarters are there? 2. So it's 2 out of how many quarters? Well, there's 3 and 2 together. So we'll add those numbers up. 2 plus 3. So we go ahead and do some work here. We've got the 4 over, and then we add up these numbers. This makes 6 plus 3 makes 9. Here we're multiplying. We have 2 out of 5. So the probability of selecting that $1 bill is 4 out of 9. Probability of selecting the California is 2 out of 5. Well, to do both of them together, we're going to multiply the 2 probabilities. So you can look for cross-canceling or reducing it all up and down or diagonally, but there is none. So we just multiply across. We get 8 out of 45. And so that's our probability, is 8/45. So 8 out of 45 chances of selecting a dollar bill and a California quarter. Taking a look at the next one, there are 10 true and false questions on a test. You do not know the answer to 4 of the questions, so you guess. What is the probability that you get all 4 right? Well, there's some extra information here. We didn't need to know that there are 10 questions on the test. We don't need to know that. All we care about is this part. We don't know 4 of the questions, and so we guess on those 4. So it's either true or false. We do need to know this, that they're true and false questions. So it's a 1 out of 2 chances of getting it right. So the probability of getting a correct answer would be 1, because there's 1 correct answer out of 2 choices, true or false. So we added those numbers together, and that's how we're getting the total of 2. So the probability of getting a correct one is 1 out of 2. Probability of getting 4 correct, well, what we're going to end up doing is taking the probability of just 1 of them. And so we have the probability of 1 is 1 out of 2. That's 1 of them. Probability of another one being correct is another 1 out of 2. Probability of another one being correct is another 1 out of 2. And the probability of the last one being correct is another 1 out of 2. And you just multiply all of these together. And so we end up with 1, 2, 3, 4 ones being multiplied just gives us 1. 2, 4, 6, 8 is what we get when we multiply these 2's. That's if I add them. If I'm multiplying, I have 2 times 2 times 2 times 2 gives me 16. And so there it is, 1 out of 16 chances of getting them all correct. Well, taking a look at our last problem here. There are 8 boys and 4 girls in the after-school club. 1 boy and 1 girl are being chosen at random. And to help with the school carnival, what is the probability of Sarah and Phil being chosen? Well, let's do this. Since there are 8 boys, they're going to choose 1 out of the 8 boys. They're going to choose 1 out of the 4 girls. They're 2 separate events. And so it doesn't matter whether Sarah got picked. The chances of Phil getting picked are not affected by Sarah getting picked. So we've got 2 different events, 2 independent events. So the probability of selecting, let's go with Sarah first, is going to end up being 1 out of 4 because she is 1 girl out of 4 total. Now the probability of selecting Phil, we're going to multiply them because we've got that idea of the fundamental counting theorem and how many different choices we have. So we're going to multiply the different events. And so to pick Phil, he is 1 boy out of 8 total boys. And then we just multiply these numbers together. So the probability of selecting Sarah and Phil, again, the key word is and, so when we see the and, that's when we multiply the probabilities. 1 times 1 is 1. 4 times 8 makes 32. And that's our probability of selecting Sarah and Phil. And so there it is, 1 chance out of 32 different chances. All right, well, those are the types of problems you're going to see on tonight's homework. Good luck.